Okay. I think I guess got a pretty good length or volume. What is volume if not 3 lengths? Okay, so what was I gonna do? Oh yeah, so shoot, I should have prepared better. Let me bring one thing up. Do I ever prepare well for a stream? Joseph, congrats on the first. Where is this book? There we go, finally. Maybe it's in this one. Just trying to get a formula here. A formula. Here we go. Get my snipping tool. I'll explain what I want to do in a minute. While we're here, may as well grab this formula too. Hey, Boston. And then I'm going to grab... up to you, yeah. I just can't get Laplace out of my mind. Okay, so... Shoot, I need to copy more, actually. One up to there. Yeah. Okay. So, I spent basically all my Saturday stream, plus multiple other days off stream, trying to solve this problem. I eventually did it last night after a lot of anger and frustration. Been doing a PD with Fourier transforms, nice. I should have just added this one onto the pile for you then. I hope that yours went smoother than mine did. But yeah, so I finally figured out how to solve this Laplace equation. It's actually if you know what to do, it's really simple. It's incredibly difficult if you don't know what to do. You could say that with every math problem, I guess, but hey Clonk, yep. That's the spirit. I hope your day's going well. 90% of the way there? Okay. Yeah, Dessen. So actually, yeah, just for emphasis, let me show all my scratch work for this problem up until my solution. I'm almost there. Okay, no, that's not it. Okay, so from here, this is page 3. Scrolling, 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 scrolling. Page 12 is where I actually solved it. And I figured out actually a lot of the stuff, the work I was doing up here, it was just wrong. I was proving the wrong thing. I wasn't even doing it right, which was even more frustrating. The way to solve it, I guess the original problem is like, it's basically this right here. Solve a Laplace equation for temperature. You have a small circle being held at 0 degrees and a bigger circle being held at 100. Find the temperature between the two circles. The geometry is kind of complicated. You could probably do it with polar coordinates, and I kind of want to try doing it in polar coordinates. But there's an easier way, which is to use a bilinear transform or a Mobius transform, where you can transform it into basically this infinite strip between 0 and 1. And so that's where most of my work that I just scrolled through was working on. Basically on that infinite strip, with one end of the strip being held at 0, the other end of the strip being 100. It turns out you can make these boundary conditions even simpler. You have to see all these numbers and letters together? Yeah, clock. That's the thing that I'd love to change about my stream. Make it more accessible to people who don't know math. It's just a difficult problem to solve, though. Yeah, no, this wouldn't make sense to anyone who hasn't spent a long time like studying math, unfortunately. I appreciate you being here, though. Anyway. So yeah, if you want to supply these boundary conditions even further, there's a clever substitution you can do, which is if your solution is t, you can name this new function tau, just whatever you want. That is t minus 100 times u. And what that does for you is, first off, the substitution is fine, because if you plug this back into Laplace's equation, you get another thing that satisfies Laplace's equation. But the advantage of doing this is the minus 100u, it leaves this first condition alone, but it changes this second condition to be 0. And that's easier to work with. Yeah. Oh, does that have a name? Duhamel's principle? I want to Google that. Oh, it's like a generalization of variation of parameters. Maybe it is, but Wikipedia is always so general that I have a hard time telling. I don't know. Anyway, it may or may not be that principle. Actually, I should have been explaining it from up here. So yeah, so now with these like simplified Dirichlet boundaries, now is a good time to take a Fourier transform. I did it in V because it seems like you kind of have to, because your boundary conditions are in U, so you don't have much else of a choice as far as I can tell. And the part, and so you can get a sum of exponentials as you usually do for a second order ordinary differential equation. The part where things get haywire, or where they got haywire for me, is that once you apply the boundary conditions, you find that a of lambda equals b of lambda equals 0. And that just, usually that means you've done something wrong. So at this point, I was like, oh man, I can't even solve a Laplace equation with Dirichlet boundaries. This is like the simplest PD you can possibly have. And I've still done something wrong. Yes, I imagine this. Did I do a double tilde on that tau? As it turns out, I think this is actually right. I think you were supposed to find that tau, I guess, yeah, tau hat of u comma v equals 0. Partial u, partial t equals, that's true, Zach, yeah. So yeah, as soon as I found that, I'm like, I had to have done something wrong. But after spending another few hours just like feeling stupid, not knowing what to do, I was like, okay, let me just believe that this is right. And just kind of proceed anyway. So I plug it back in there. You get that t is 100 times u. So I put right there. Technically, I untransformed it, but you know, the Fourier transform of 0 is 0, so it's not too exciting. And so yeah, I was like, just 100u seems way too simple, but it is 100u like in the transformed plane for this vertical strip. And the more I thought about it, the more it makes sense that there's no dependence on v, because Fourier transforms kind of need things to decay when they go to infinity. But this definitely, like, this is not supposed to decay when it goes to infinity. So I feel like it kind of makes sense that v just needs to drop out because of that, if it's going to work. So yeah, if you just believe that's 100u, you can go back to your Mobius transform, invert it, and go back to x and y, which are the coordinates involving these circles, and you get this bad boy right here. And actually, let's plug it into Desmos. Oh, there's a mob justice. Exclamation point mob, and then a username if someone needs to be punished. Or you can just have a self time out too if you want to time yourself out. Mod. Ooh, nice. Actually, no, I'm not. I'm going to leave the 100 out because 100 is going to make it harder to see. Poor Zach. Technically, Zach could vote back at famished. This is a fair fight. It's 2y squared. Divided by x squared plus y squared. Oh, and this is hard to read. Oh, Zach lost. All right. Sorry, Zach. You'll be back in 30 seconds. We love you. There we go. And so get clapped. Acknowledging that, like, you know, this only goes as high as 1. It should go as high as 100, but that's, you know, going to be really difficult to read on the Desmos graph. The solution actually looks pretty good to me, at least. Around the big circle, it's at the maximum value of 1, and then it kind of smoothly decays down to 0 on the inner circle. There is one slight issue, which is that it blows up right at the origin. And I think that behavior is okay because there's a conflict of boundary conditions right there, because like right here, it's both being held at 0 degrees and at 100 degrees at the same time. So what's really happening there? And similar, like in the very tiny space right next to the origin, like who really knows what's happening? Sorry. Welcome back, Zach. We missed you. It was a long 30 seconds. Phallus surface? Kinda. Yeah, I can see that actually. I didn't even think about that. And normally I'm on the ball with that. Zach is planning his revenge. Times me out next time in his stream. Talked about math all day, kind of tired. Just watch Netflix and eat. No worries. Desmond, thanks for saying hi. I get it. You ban the AI will have its revenge. E to the 2 AI. So yeah, even though this felt super weird, like the solution that you get seems pretty realistic. So I think it's right. Not me too. Yeah, I never finished Better Call Saul, and I really want to. Actually, yeah, I guess you're talking to Dessen. But I also want to watch Pluribus. I still need to finish Better Call Saul, and I need to either get whatever service it's on or find another way on the dark side. Do it. Okay, but the other thing I wanted to try, because I just am a masochist where I solved this problem once, but I can't settle for solving it once apparently. I want to see if, because it has Dirichlet boundaries, if Fourier sine transform does anything special, or if it, I guess it should also just work and get the same thing, but at least in my numerical methods class, they're kind of, they were saying that like general Fourier transforms work for periodic boundaries, Fourier sine works for Dirichlet boundaries, and Fourier cosine works for Neumann. And I don't know why my complex analysis book never talks about that. I wonder if it's maybe not that strict or there's some caveat to it. But I'm just curious to see what happens with this thing with a Fourier sine transform. We do need to figure out the second derivative for Fourier sine transform, though. Ugh. Wait. What? Is this a typo? That should be an X. Hey, Puika. Surely that's an X. I'm gonna make that an X. Because there's no way you're gonna have a function of K at the end if you're integrating in K. So we're gonna integrate by parts. So UV minus VDU. Cosine kx dx. Oh, okay. I copied this promo down hoping that I would be able to just use it on this part, but this is now a cosine, so we can't. I could go to one for cosines, but I don't want to get another screenshot. For this thing, when x equals 0, we get 0. When x equals infinity, we're going to assume that it goes to 0. And verify it later. That's what we've been doing because this is an applied class. If you're doing a more pure class, you do something else apparently, but yeah. Hey Doomwood, hope you're doing well. It depends on the question, Doomwood. If you want, you can hit me with it though. It's kind of a busy time in my life, so I can't get super deep into a question. Cause I do have things that I just like need to get done, but it's short enough. We can take a look at it. Simple harmonic mechanics? Okay, no, never mind. I'm sorry, I can't do that. As soon as I see the word harmonics, I just know that I can't. I'm sorry. Oh yeah, Slim? I saw you too. I saw Tsuki too. Sure. Shout out to Fembox. Make him stream. We get minus K UV minus VDU. But there's already a minus from DU, so we'll make it plus. Oh yeah, I would love to watch a Fembox stream. Zach, I think that the plan is Slim is trying to like bully Fembox into streaming. So hopefully yes, but I don't know if he's actually going to do it. Oh, to do it, I'm sorry. I said that I can't do it. I don't know simple harmonics. I'm looking at the question now, and I'm confirming that I don't know how to do this. Someone in the Discord might know how. But yeah, I just went on a whole thing where I explained that I can't get in too deep into a question right now. If it's one that like I knew how to do, I would do it, but I have a lot of stuff that I need to get done, unfortunately. Oh, that's true, Zach. No worries, Doomud. If you don't mind hanging on for 30 minutes though, my friend Dr. Gold, aka Actual Education, will be streaming. He's the second link in that list. He would be able to help you out. He has a website where you can like submit that same screenshot. Yeah, no worries. Thanks for calling that out, Zach. Hey, Slim, if you are still here, and if not, I'll send you a message. You kind of really piqued my interest when you were talking on your stream about like those math philosophy books. Oh, you are here, nice. Like I'm kind of tempted to do like a mini reading group on it over my winter break. I just wanted to like throw it out there that if you're interested in making like a collaboration, to let me know. F hat S of K. Got into sumo recently. Really? Like, I've been, Twitch has kept on recommending me a sumo channel. I never really watched it though. Is it from that? Or like, do you get into it some other way? Yes, sounds good, Slim. I was thinking of putting a feeler out into my Discord of what type of book people might want to read. That there was one that you talked about that looked kind of like the most approachable for someone like me who doesn't know much philosophy. Okay, what am I doing with this? Okay, so we're gonna do Fourier sine transform in V. So minus k squared You wrote a copy of Think About Mathematics by Shapiro. Yeah, it was one of those Shapiro ones. I have a little text document. Yeah, I think it was. Ooh. The other one that I remember you mentioning on stream was Philosophy of Mathematics by the same Shapiro. I want to say that one sounded a lot more technical for people who know more math or know more philosophy. Sorry, but I don't remember. Whichever one looked simpler is one that I was interested in. I kind of want to do like a general like research on it too, though. So I guess we're getting the same thing for tau hat S. Philosophy of Mathematics by Oyston Lenebo, but the Shapiro book looks better. Okay, fair enough. I should use lambda. So I think I'm getting the same thing. This is kind of lame. Okay, okay, this is a waste of time. This is gonna become the exact same thing as what I did up here. I was hoping it'd be something more interesting. I don't know what I was hoping for, but okay. Lost audio? Oh no. Oh, I mean this. No, this is a thing that actually I guess if there's no point in me saying this out loud. Some lost audio. More for mid-December. Oh, okay, cool. Jed, nice. Oh, you had a good streak going for a while. I'm sorry you lost it. Hello, Lolo. This thing I was thinking of more for like mid-December because I'll be on break and I'll have more time to read a book and let other people have time to read the book too. Yeah, that first 99 streak you had, was a heartbreaker. Okay, awesome. Yeah, I was thinking of making it like a small version of like the reading groups that I used to do all the time. Where it's like anyone who wants to can read the book and hop on and like talk about it. Okay, so the only thing I wanted to explore with this was polar coordinates. What does the Laplacian look like in polar coordinates? And how do you do the Fourier transform of that? So there's going to be like a 1 over r squared that I don't know how Fourier transform will play with. Laplacian operator. Really Wikipedia will say it, right? Oh my god, I just encountered this notation for the Laplacian. And it's the worst. Why would you ever use this for the Laplacian? I forget where, but like this is taken, dude. Like don't use delta for the Laplacian. Radon transform? Is that what I would want? Yeah, like if I have the Laplace equation in polar coordinates, can I still use a Fourier transform? Oh, it's related. Oh, okay. Bugsy Do Right? Thank you for the follow. Sigma? That's even worse. What's the OG delta symbol? What? That's the OG delta symbol. Sigma nuts? True. The Laplacian is the OG delta symbol? In my entire life... Wait. No, I'm getting confused on this. Okay, wait. No, but, sorry, I was about to say that this should be the gradient, but it's not. This is, I guess it's just change. But, like, del squared or nabla squared is so much better because it works so well with gradient, divergence, and curl. Like, why would you ever use delta? If you do PDs, that's taken for the Laplacian. I don't like it. Bugsy, the theme of the stream is that I'm a math grad student who's working on homework, and I also take questions from chat and will do my best to solve them. Right now is a really like kind of busy time for me, so I'm not able to do as many like help questions as I would like. But that's basically how my streams work. The thing that I'm like currently doing, sorry if I'm over explaining this, but I see you're a first time chatter and welcome in. The thing that I'm currently doing is I was kind of, that's not the right window. Is I was looking at this partial differential equation called Laplace's equation, and this is a homework assignment that I had to do. I figured out the answer, but I was kind of interested in alternative ways of solving it, and so that's what I'm kind of researching right now. And I don't know what your math background is, so I'm sorry if I explained that either too much or not enough, but I hope... Let me know if you have a question or anything that you'd like to talk about, I guess. It's a tripod website. Thank Robert Murphy for your frustrations. Earliest uses of symbols of calculus. Ooh, nice. Del is way overused in PDE in differential geometry. Ooh, prime was Lagrange. I assumed it was Newton. Wait. Okay, yeah. There's no mention of Newton. Really? Well, what did Newton do? Newton. Oh, dots. True. Yeah. Remove all the del for math. Newton's notations look too strange for our taste. The dots are, they did become helpful when I was like looking at like some of the equations in general relativity with like differential geometry, but I generally dislike the dot. I'm not a fan of the dot. You like the dots. I don't know. I usually don't notice them. That's my issue with them. I'm looking for delta or del. Oh, there's a delta for change. Weierstrass made the limit notation. Nice. Oh, but there's an equal sign. That's kind of gross. Yeah, dots, like the same way you would use prime in physics, you sometimes use a dot. And I've seen the dot also in my biology class. Usually it pretty much always means time derivative. Whereas a prime could kind of be more general. Oh, hey, here's del. Oh, rotated nabla. Ew. Hamilton. No. Who even are you, Hamilton? Is that like the Hamiltonian dude? Probably. An elementary treatise on quaternions. Oh, this looks so bad. Who would have thought that math notation used to be even worse? Oh, nice. The first use of the Laplacian was in the context of E and M. Nabla squared is also used for the curvature tensor in differential geometry. Oh no. I can kind of imagine that because curvature relies on the second derivative, right? But still. It's fast with vectors, it looks weird. Oh yeah, that's true. Covariant derivative. Oh, okay. That was an interesting read, Zach. Thank you. The Simpsons package for LaTeX. Make Homer the Laplacian. I can't imagine Bart, or maybe Lisa, because they have the spiky hair. Kind of looks like a triangle. That looks like an alien. Mathematics is the art giving the same name to different things? That's kind of deep. I like that. An old Lee algebra book, that's the worst notation. Oh god, okay. Can you do a Fourier transform with Laplace's equation in polar coordinates? Yeah, so it's like, that's the Laplacian. Oh, no, I want the angular dependence. I have an angular dependence. Do I have an angular? Yeah, I do. Oh, yeah. I guess it's going to be kind of disgusting. It's not that disgusting. It could be a lot worse. So that's the thing I would want to take a Laplace transform of, but it's the 1 over r and the 1 over r squared that I feel like are going to mess it up. Hankel transform? And the standard notation is a bit annoying to write on paper. Oh god. Huh, so this does exist. I don't think I want to try to do this then. Wow, you get the same formula? If there's no angular dependence at least? How does it look if there is? Oh, it uses Bessel functions. I just learned about using these as a basis for a transform. Okay. Well, and by learned about them, I mean, I learned it was possible to use them. I didn't learn anything actually about doing it. Gothic letters? Oh, is that like the R they use for real numbers? Is that a Gothic letter? Like the weird scary R? Yeah, like that font. That would be terrible to write by hand. No, I actually yeah, it's not the double R. I think is it Math BB? No. Is it Math Cal? No. I don't know. I forget how. Oh wait, it's that R. For maybe it's for maybe I got it mixed up. It's for the real part of a complex number, maybe. It's probably hard to see this. Let me compile it. It's that bad boy. Example for GLNC, invertible n by n matrix with complex coefficient. Oh. Is that what that meant? The thing that you sent? Oh, okay. Yeah, that one would be terrible to write too by hand. Oh, hey, they literally have a section on applying it to the Laplace equation. This is cylindrical. Why is there no theta here? Huh. I wonder if there can't be a theta dependence. Oh, in the axisymmetric case. Never mind. Well, what? Show me the full thing. This is cheating. Quantum mechanics dagger notation for that adjoint operator is also horrible to write down on paper. I've heard that quantum mechanics does that. But isn't that really easy? Like, people just basically make a cross. Or is there something else? Too much like oh, that's fair. I didn't think about that. You raise a good point. You have seen as real and imaginary? Yeah, the R and I want to say I've seen it used for the R for real numbers. I don't remember though. I want to say there's also like a weird N I've seen for natural numbers. Okay. So really the only two things I want to accomplish today, or at least work on stream anyway, was like taking up this Laplace's equation question. And I could get cracking on my scientific computing homework. I haven't really even started though, so I'm a little bit scared. So it usually is a slow start for this question, or for this like class. Sophie Germain proved to the world that even a woman can accomplish something in the most rigorous and abstract of sciences. Oh, nice. I remember learning about Sophie Germain from someone in the stream. I don't remember what she did. Oh, under a pseudonym with a man's name. Interesting. Elasticity theory, Fermat's last theorem. Wow. Man, that's some BS. At least there's a nice like legacy though. Yeah, that sounds right. Wow, that's a hell of a PD right there. Sophie Germain's theorem. PB an odd prime. I hate that phrasing, but okay. What the hell? Okay, P is not a Pth power residue, whatever that means. Oh, residue is like remainder, I guess. I don't know. Germain showed that any counterexamples to Fermat's theorem for p greater than 5 must be numbers whose size frightens the imagination. Around 40 digits long. Wow, her theorem is only known because of the footnote in Legrander's treatise on number theory, where he used to prove Fermat's last theorem for p equals 5. Crazy. A death mask? What is a death mask? Wow, that's dark. Intentional deformation of the skull practiced in early modern France. That's a little... I learned two things in this caption, and I don't like either of them. No, I don't think so. Is that where Game of Thrones got it from? Wow, to serve as a model for sculptors in creating statues? Huh. Wild. Oh, good. There's a life mask, too. That's much happier. Well, you learn something new every day. The Man in the Mask? Huh. Okay. All right, how should we start our answer to this question? Let t of xy satisfy Laplace, I guess just the Laplace equation to match the phrasing of the question. Satisfy the Laplace equation. So, slash frac slash partial squared t slash partial x squared plus slash frac slash partial squared t equals 0. T of xy equal to 100. I guess we could even be... No, I don't want to be that fancy. Small circle and t of xy equals 100 on the big circle. I was gonna be fancier. No. It makes it less readable. I was going to instead of saying t of xy equals 0 on the small circle, I was gonna say t of x, comma, and then instead of y, plug in the equation for the circle. But that's gonna look like a real mess, and it's gonna be hard to understand what's happening. So it's fancy, but it makes it harder to read, I think. The Man in the Iron Mask in France refers to a real unidentified political prisoner imprisoned under King Louis XIV, who became the subject of historical mystery and legend. Ooh, okay. I can see them making a movie about that. Can't take photos, just plaster their face. That's true. If they're dead, the mask comes out better because you don't have to make breathing holes. It's a really good point. You know, I feel like you should make a death mask for someone. I feel like you would be good at it. Can be simplified by applying the bilinear transformation found in problem 1. W of z equals slash frac 2z minus 1 over z. You'll make mine? You know, thank you. That, you know, also sounds like a threat, but I appreciate it. I don't want some amateur to make my death mask, and I feel like you would do a good job with it, Boston. So give me a selection of styles. Perfect. Did that that I feel like that's an idea for a website. You can like order your death mask ahead of time, and there's a bunch of like customizations that you can like. They have a little thing that it takes you through on the website for all different customizations. I feel like my light is like a little too cold. It's too warm. It's too cold. That's just right. We're going by Goldilocks rules. transforms. We obtain it becomes finish your calculus workbook today. Nice. Oops, not UV. How long was it? Yeah, I guess like you say a whole like workbook. I imagine is that something you've been working on like throughout the semester then, or like that sounds like a lot of work. 2 to 3 weeks of doing 3 hours every day. Oh, it's extra. Okay. Dang. Well, nicely done. It's a lot of work. I bet. When I took my first calculus class, I basically had to spend the first like maybe month of it studying every day. But eventually it kind of clicked and the rest of calculus just kind of fell into place. Bought it for myself because I suck. Now I'm average. Hell yeah. Nice. The boundary conditions can be further simplified by making the substitution tau of uv is equal to t of uv minus 100u. Tau still satisfies Laplace's equation. Ooh. I am not in it, but I should be. I didn't realize that we had a Discord. Let me go and dig that up right now. Oh, no. No, you're good. Oh, sorry. That was an ad that just played for a second there. Productivity Cafe. Messages failed to load. What the heck? Okay, there we go. I'll take a little peek around there. What channel is it in? Maths? Okay. Oh, that's nice. How long we should try out color cone before? Under club rooms. I'm looking at that channel. I don't see it. I saw you posted you just finished reading the Essential Calculus book. I'm scrolling up. Oh, that drawing you made of the croc is so cute. Oh, I see it. The picture with all the workbooks. Let me show this. Color code? Oh no, I just joined Holnobi's Discord and I saw he gave you a shout out earlier, and I thought that was just nice to see. Oh, these are some hardcore calculus workbooks. Oh yeah. It was like a little like post in the math channel. Yeah, I see Chebyshev polynomials there. Okay, well you said calculus workbook. I think like you were first learning calculus for the first time. But no, this is this is advanced stuff. These look good though. Yeah, that's super nice of him. I hardly get to watch him because stream started like midnight my time. Hey Skirtle. I already forgot a step. Hey Lucas. Well, thank you for letting me keep you awake. I realize you probably want to fall asleep, but if you want to ask me about a problem, this is like a better time now. But I don't want to talk about math when I'm about to fall asleep, so no worries if not. Okay, so there's an issue, which is Laplace's equation is not invariant under bilinear transforms where the bilinear transform is 0. I need to address that. No, the derivative. Oh god, I need to check this. Notebook of Wonders, answer my question. Further. Formal mapping. There we go. Yes, it is the derivative of W. Okay. Ooh, thank you for the 5 streak. Gotta build up those channel points for the next VIP redeem. Hey, I'm going to pronounce this wrong. Shanner Millen? Sorry for... I'm sure that's not how it's pronounced, but... Well, watching of solving math is so enjoying. Nice. Welcome in. I'm glad you're enjoying it. If you want more, you should check out Actual Education. He also streams on YouTube. The second link in the list that'll pop up there. And I think he's actually even streaming right now, probably. But if you ever want like more stuff like this, he's also good to watch. This is only true when d by dz, well, dw dz is not equal to 0. Now that I'm not yet done with my... Wait. Now that I'm not yet done with the Olympiad questions, but I'm going to refocus my focus on another type of math, just something I thought about, which solves the problem divided by 0, partially. It also broadens the horizons of current algebra by not breaking it. Okay. Yeah, I mean, if you can do that, that sounds like it'd be something interesting. I've been saying Lucas. I haven't been corrected, at least. Okay, yeah. Our sleep schedule's perfect. Here, the derivative of w of z is never 0 for finite z. Is that right? Where did I check that? Yes, I checked it here. The derivative is 1 over z squared. And we don't care about z equals infinity here. I pronounced my name too correctly. Okay. That's better than too incorrectly, I guess. ChatGPT said it. Yeah, I wouldn't. For something like that, ChatGPT, I really wouldn't trust it. ChatGPT just tends to agree with whatever you say. Let me see if I can find it. There was a news story that I heard about. Yeah, if you want to use it like Google, that's fine, but asking it to check your work is usually not a good idea. I'm trying to find it. It was someone who had like a business idea that they were asking ChatGPT if it would be a good idea, and ChatGPT said yes, and they went on to like invest a bunch of time and money into it, and it just like fizzled out and became nothing. I want to say. I can't find it though. Yeah, I can't find it. I'm getting like bad search results because I don't know how to search it properly. For like ego, ChatGPT is better. For actual good information, Gemini is better. Maybe, yeah, I wouldn't know. Okay, that's fair, Lucas. At least they tried, I guess so, but maybe they would have tried something else if they got advice from a person who actually knows about business. Yeah, it means like you don't have guidance on how to like advance the work, but it also means that you've discovered something cool. But that's kind of like math, like research works. You're supposed to be doing new things and kind of having to forge your own path. Okay. Because slash frac slash partial squared slash partial x squared. No. Oh, u. uv. Well, ugh, okay. I'm gonna do this out in excruciating detail that probably isn't necessary. Is it bullshit like that inverse sigma, or is it actually useful? Yeah, I mean, yeah, that's always the thing when you're doing something new with math. Is what you're doing legit or not? Uh, so the point is that both of these linear terms derive to 0. I messed something up. Oh, there's no slash. So where my knowledge math goes right now, I think it's for the various interesting to spend some time on. Yeah. Maybe time to start learning my trig identities. Oh. This that I have bookmarked. I just can't be bothered to learn these. It's annoying. I like being sneaky. You could Lucas vibe with category theory. Maybe. As far as I know, Lucas hasn't learned about it. Hey, Famished. Thanks for the lurk. I think of category theory as like it's what you do after groups and rings and stuff. Color cone can speak to it better than me, but I think there's like a level above those. I don't know very much about it at all though. Um, all I know is that it's math. The same, basically. Some way it feels more like a philosophy of life. Okay, so like as far as I don't, so algebra, um, at least for the way that it was explained, like, it's not like to me, but like, the way I've heard it explained on stream is that abstract algebra talks about all operations and sets of numbers at once, or at least a lot of them. Oops. And that's what you're doing with groups and rings and fields. Whereas category theory talks about all or a lot of algebras at once. So I don't know how true that actually is, but that's kind of, it's like another level of abstraction. Algebra is applied abstract algebra just normal algebra? In a way, yeah, you could call it that. Abstract algebra does have actual applications though that aren't just that like meme like that. Clip it and ship it. Category theory is not very part of algebra. It's more like a language that allows you to connect many fields of math. Like, okay. It should work. Yeah, there you go. It just took a minute. But let me find it. Oops, not. Never mind. Most group theory is for mathematicians. There's a book that I heard of called Group Theory for Chemists, which I never realized that chemistry had anything to do with group theory, but it kind of makes sense. So I would never imagine, but abstract algebra actually does have direct applications outside of math. Yeah, I mean, uh, if you're interested to hear more about it, Lucas, we might be able to badger Color Cone into doing a stream where he explains it to you, like a bit more about it. The only group theory I know about chemistry are the groups of theory nerds in my class studying chemistry. Hell yeah. No one likes a nerd. No nerds allowed here. Wait, what? Wait, what? I don't know what that wait, what is too. Cryptography? Oh wait, or yeah, I'm saying wait, what to color code. Maybe you're saying the same thing. Probably most. Oh, is that an application for algebra? Cryptography on elliptic curves? Is that? Oh, about abstract algebra and chemistry? Yeah, no, apparently there's an overlap there. I didn't realize that those would be abstract algebra. Wait, wait, what, wait, what? I think you use it for like symmetries of molecules. Group theory can help with that. That's what I was imagining. Oh, wait, this is for inorganic, really? Never mind. Maybe you should throw out what I said. I thought with like the whole thing with like chirality and stuff that molecules have in organic chemistry. I've never taken inorganic chemistry in my life, or inorganic for that matter. I thought they'll be used for that. Maybe they also are, but huh. Oh yeah. Color code streams, at least sometimes. Group theory becomes very important in physics. Really? Maybe like quantum physics, if I was guessing. Yeah, and so I've been kind of tempted to like, I mean, it wouldn't be anytime soon, but like read a book like this that talks about group theory, which I generally haven't liked what I've learned, but do it in a really applied context. If I don't know anything about that context, like chemistry, that can make the group theory more interesting to me. Interesting color cone. Most of the time, groups are related to applications by the means of representation theory. Okay. That's good to know, because I've heard of representation theory, and I've never really known what it's about. Group acting on vector spaces. Okay. Color code knows everything. Where am I in this answer again? Group theory is too hard to study directly, so the idea is to reduce the questions about group to linear algebra. Really? You have groups that are too hard to study directly? Huh. Many particles are defined as irreducible unitary representations of the Poincare group. A 10-dimensional non-abelian Lie group. Oh, okay. So I knew that Lie theory or whatever was important in physics. Lie algebras or whatever. I don't know. Whatever that means. Okay, I can imagine how a 10-dimensional thing will be hard to... A 10-dimensional non-abelian thing would be hard to study, I guess. All coordinate transformation of Minkowski space that do not change the space-time interval between events. Ooh. Minkowski space is flat space-time, right? That's a hell of a mustache. That is a nice, like, handlebar mustache. Holy crap. The glasses need some work. Those glasses kind of suck, but the mustache is on point. Oh my god, I didn't mean to zoom in that much, but let's just, you know, while we're here, let's just appreciate the mustache even harder. His ears seem really small. I don't know why I'm just analyzing him. I just want to see, Minkowski space is the flat space time, right? It's a mustache in Minkowski space. It is? Okay. They are part of that era. Okay, yeah. The space-time with special relativity. Right. May I have an interesting Olympiad question? Yeah, sure, Lucas. Um... Interesting. Okay. Yeah, I was about to say this sounds like or maybe I'm thinking of the wrong thing. 10 Degrees of Freedom. Translations, reflections, or boosts. Okay. Question 22. Oh, what is this tuba in this song? Wow. Wow. Ah, okay, never mind. Ooh. It's not the tuba. Plop. I like that for a tuba sound. Minkowski space is a space-time without your mom. Oh, that's such a nerdy joke that most people get. That's a really nerdy your mom joke. The joke there is that Minkowski spacetime is basically spacetime without any like matter in it. And so I think it's a fat joke. Is what's happening there. Yeah. Okay, 8 right-angled isosceles triangles are placed in a regular octagon as shown in the figure. This leaves an octagonal hole in the center. Sure. Do they always leave an octagonal hole? Could you, if you made them bigger, would they just fill in the octagon? Probably not. Note P1 for the perimeter of the original octagon and P2. Oh. Zone Ranger with a prime. Thank you so much. I hope your day is going well. I appreciate that. P1 for the original, P2 for the inner. We need to find their ratio. Really? I bet there's a quick answer to this if you're good with geometry. $20 might be interesting. You don't even need to translate it. Oh my god. Okay. That looks like a weird one. It could be interesting. So these are isosceles right triangles. I assume we need to use that. A similar joke with flat space. Can any of these obviously be thrown out? No, they're all less than 1. I was hoping to have an easy time with like being able to throw out like 2 of them or something if they were more than 1. Ooh. No. Okay, well, if we just say that P1, maybe we should make P1 8. We can make it whatever we want as long as we're consistent, right? So if P1 is 8, these are all length 1. Which means all of these things here are also length 1. all of the legs of the isosceles triangles. And we love legs here. Oh, I need to be careful with how I'm labeling these. Like, all of these things are length 1. Root 2 plus 1. Well, that's not good. That's not an option. Oh, wait, this isn't that bad. Because we can find the hypotenuse of the right triangle and then just subtract off this 1. Yeah, okay. This is the way. So by Pythagorean theorem, the entire hypotenuse is root 2. But the thing we want is just this bit here. So that's going to be root 2 minus 1. That's really bright. Oh my god. So that means that the perimeter of the inner polygon, oops, is 8 times root 2 minus 1. So that means P2 is that. And we took P1 to be 8. So P2 over P1 is 8 root 2 minus 1 over 8, which is root 2 minus 1. Nice. Just crossed B and forgot about it? You know, I think you did the right thing then. It's got 20. This proves that square... Really? Oh, you just flipped the fraction. No. We proved square root 2 minus 1 is irrational. I could kind of see that, but I'm not sure how. I don't know. This is an interesting way. Like, this feels like how you would prove something like that. I don't know how you would come up with this if that was the question you were starting with, but okay, so yeah, like we said, I don't think we need a translation for this one. Find a natural number x such that x to the 4th equals this. And clearly we break out our calculators here. No, how would you do this? There's no common factors. 9 kind of messes that up. What's in the gaps? We have 5 to the 4th, 7 to the 4th. It's kind of an interesting... Like, what is this pattern? Oh my god. It's 4:15. It's basically nighttime. I've had that thought pretty much every day the last like 2 weeks. I don't know why I continue to be surprised. Then it's how hard is it to not give hints? I know there is a general formula for the sum of powers of 4. I don't know what it is off the top of my head. Even if we had that, it wouldn't be that helpful, I think, though. Is this better to do backwards? Like, look at the possible answers? Like, 41 is kind of an outlier. Like, it's probably not going to be 41. You generally don't need that kind of formula? Okay. Can we tell if it's even or odd? Like this is even plus even plus even plus odd plus even. So the answer is odd. Oh, well, okay. It's either 15 or 41. And 41 seems large. I'm going to say it's 15. Well, it's because an even number plus an even number is another even number. So these are all even numbers. So that means if you add those four together, it's even. And then this is an odd number because there's no twos in it. So 4 evens plus an odd is odd. Look, mod 3. Really? Oh man. Which Fermat theorem is it that lets you simplify things like 4 to the 4 mod 3? Oh wait, or is 4 to the 4 mod 10? Really? Or actually, is 4 to the 4 still 1 mod, or yeah, 1 mod 3? Does the power of 4 change that? Don't think you need any theorems? Really vague blur. Or is mod like multiple? I don't think like 4 times 4 mod 3. That's probably not the same as 4 mod 3 times 4 mod 3, is it? I forget how mod works. It's been a minute for me. I know it's not open book, but I'm Googling stuff. I know that zone, but I guess I was confused by the power. I'm just, I guess I'm forgetting. Oh, it's like that. Okay. It is multiplicative? Oh, okay. Huh. Yeah, I haven't done any like slightly intense modular arithmetic since like probably a year and a half when I was trying to study abstract algebra. So okay, let's do this the right way. That's not just like intuition with even and odd. Although I think that's probably in a competition is probably the best way to do it. I guess 4 to the 4 mod 3 is equal to 1 to the 4 mod 3. Just copying down what Zone Ranger wrote, which is 1. 6 to the 4 mod 3, that's going to be 0. 8 to the 4 mod 3 is 2 to the 4 mod 3 is oh my god, what is 2 to the 4? It's 16, right? It's 16. 1. Oh, -1 is easier. True zone. I forgot that you can use negatives. Vossen, you're going to bed? All right. Thank you for hanging out. I'll see you around. Okay, for this we should use -1. Oh, 1 second. Okay. -1 to the 4 is 1. Okay. Mod 10, it might work too. So this is 3 mod 3, so it should be 0 mod 3. And 15 is 0 mod 3. Nothing else is. Oh, wait, no, sorry. 18 is 0 mod 3. But you could eliminate 18 with the even and odd thing, I guess. I have a friend who gave a counterexample to Terrence Tell's claim on Math Overflow with an Among Us shape. Really? That's legendary. Mod 10. I don't know. We could look at mod 10 too and see how that works out. It might also work. This is maybe a little bit harder to do mentally. Is why. Wait, why is this happening? Well, 1 second. Sorry, I have an old laptop that I'm trying to wipe so I can take it to a recycling place. The issue is that I had a... It's a Windows laptop, but I installed a Linux partition on it, so just like a section of it. Like I have the option to boot into Windows or Linux. And whatever I just did to wipe the laptop doesn't seem to have gotten rid of the Linux bit, so I'll have to figure that out. Not because it's easy. That's fair. Yeah, so Lucas, mod 10 might also work, but I kind of like Zone Ranger's rationale there that it's just easier. Is an Among Us character? Oh my god. So what's the original claim? VB body in R3 bounded by a smooth sphere with principal curvatures at most 1. What? Excuse me? I was reading that. I maybe understand that. Turning off the somewhat unimportant outer walls. Taking away the meme factor. This is wild. Oh my god. This is so long. This was taking so long to write up. Are people, like... This is Math Overflow. Like, I think... You're not allowed to joke around that much, right? I had Terry Tao, look at that. That's cool. No one's addressing the Among Us part of it. It's funny. Okay. Yeah, like I guess I basically did it mod 2 without actually doing it mod 2 with my even and odd thing. Uh, Trebles 28 and 29. Let's see. Let me get rid of. I have too many tabs open. I almost can read this. It just looks so similar to English. Okay. Some of the areas of the two squares in the figure below. Hey, Hell Dog. How's it going? We don't have the measures of any of these angles. Really? We can figure this out just with these 2 bits of information. Yeah. That's true. Do 2 cosine theorems and sum up. Oh, wow. Because you know these are right angles. Okay. So yeah, Luke, so I guess we're gonna use law of cosines again. We're gonna do it on these angles here. So starting with the lower triangle, I guess I'm gonna call these A1, B1, A2, B2, just for lack of a better name. 5 squared is equal to A1 squared plus B1 squared minus 2A1 B1 BB cosine beta 1. And then we also know, oh wait, these are squares. So this side length here is the same as that side length there. I did hell dog. I said that that's true. Maybe sorry, I wasn't speaking up and like reading it out loud, but like I absolutely agree. Like you shouldn't let melancholy weigh on your mind. I try not to let it weigh on my mind either. Because it just kind of sometimes you need to like process your emotions and sit in it then, but if it's all the time, you're just kind of you're not helping yourself. Okay, so I see. Yeah, this will work out well. Okay, so we can get rid of one of the theta 1 or theta 2s because we have a full circle here. So the angles add up to 360. You see it? Yeah. I think I'm about to get stuck here, but hopefully not. And we know that these 2 angles here are right angles. All right, you too, Hell Dog. Thanks for saying hi. I hope that whatever is weighing on you doesn't weigh for that much longer. We know that theta 1 plus theta 2 plus 90 degrees plus 90 degrees is equal to 360 degrees. So theta 1 plus theta 2 is equal to 180 degrees. Or something like good day or good morning. Yeah. Gotta cover all your time zones. So I guess we get rid of the theta 2 in this equation. I bet you this is cosine of theta 1. Have a good 6:03 p.m. Yeah, I think it is, because if you take cosine normally looks like that. A 180 shift means that well, that's annoying. Should have done this in one pen stroke. A 180 degree shift means that you're shifting it like that, but then we're doing minus theta 1. It's annoying when it's written like this. No, oh yeah, okay, yeah, you're right, Puika. It's negative cosine. Yeah, okay, so the 180 degrees does a shift like that. It might be to the right instead of the left, but it doesn't matter here. And then the minus cosine theta doesn't actually matter, because if you flip it like horizontally, you get the same thing. All this to say is that this bit here is minus cosine theta 1. Now we're still not out of the woods yet, because we have 3 unknowns, a1, b1, theta 1, and only 2 equations. So we can't possibly find a1, b1, and theta 1. We don't necessarily need all of them. But we need to come up with another idea. Like, this is a start, but it's not the end. Is it raining? I can't tell. I'm open for ideas on how to get that Puik. So I'm thinking about it, but I'm not sure. A squared plus b squared. Oh, ha. True. That's our, okay. So the thing that we want is the sum of the areas of the 2 squares. And the area of the first square is a1 squared. The area of the second square is b1 squared. And we happen to have that right here. So really, we take these 2 equations and we just solve them for a squared plus b squared. Nice, Pooey. Thank you for that. So 25 is equal to a1 squared plus b1 squared minus 2a1 b1. And hopefully there's a way to do this. There should be, because they wouldn't ask us an impossible question. Oh yeah, yeah. Oh, this works out. Yeah, yeah. So thank God that this minus sign comes out in this 180 minus theta 1 thing, because as Pui says, we can just add the two equations and we get rid of theta 1. But we, like, really, we want to get rid of these two terms entirely. So the difference of signs is kind of perfect. Where like one is minus, the other is plus. So we get 34. And that's our answer, 34. Oh, well, that's not good. Technical difficulty. What? Wait, I don't know how to do math. It's 2a1 plus 2b1 because we added those up. So 17. Oh, you missed a bit of it, Fembox. Where Lucas asked about at least one more though. I don't know if it's jump. Oh, okay. You hear? Oh, okay. So yeah, you missed out on a couple of them. There's at least one more that Lucas asked about though. I don't know if it's geometry or not yet. It's also okay. Oh, did I skip over 28 and go straight to 29? So you missed out on that one. There's this like more number theory-ish one. And then we also did this like octagon with isosceles right triangles one. You want to talk about 28 also, Lucas? Let's see. Oh, Groot. I am Groot. What does Groot mean? It means big. Oh, okay. Oh, so in Dutch, do you like is that common for how you phrase questions? Like how big it is tangent AKB? Rather than asking like what is tangent AKB? That's cool. Okay. The triangle DAK sides 3, 4, 5. Is that a right triangle? It has to be. Has its longest side in common with side AD of square ABCD as shown in the figure. What is tan AKB? Okay. So AKD is definitely a right triangle because 3 squared plus 4 squared equals 5 squared. It's a Pythagorean triple. So that is a right angle. Even-legged triangle? Oh, for like an isosceles, sure. We'd spell it like this one it isn't isosceles, but we would spell it as isosceles like that. But that's a good translation for it. It's what it is. So, you're not remembering that? That's fair. I don't blame you. Okay, so what else can we do? We can figure out what this angle is here. We want the tangent of this angle means we need to make a right triangle. Ooh. Maybe there's another way to go about this, but... yeah. And so tangent of that K angle would be like opposite this side here divided by adjacent that side there. It'd be nice if there was a shorter way to do this, though. Because this is going to take quite a few calculations. Okay, if this is a right triangle on this side down here with hypotenuse 5, do the legs have to be 3, 4? No, it can't be in this situation. Because if that was 3, then you can't have this right triangle up here with hypotenuse 3. I feel like there's a clever way to get tangent here without doing this right triangle thing. Like if you combine law of sines and law of cosines in some clever way. I guess let's just start getting quantities that we know how to get. I was gonna start by getting like these angles here. Is that even that helpful though? It's not gonna be a unit circle, which is kind of annoying. Hey, Chaotic Diamond. There sure are triangles here. This is... I don't know, man. This is, I think, the hardest one that we've done so far. I don't know. Gonna go? All right. No worries, Lucas. I'll keep trying with this one, but if it takes me too long, I'm just gonna move on. Sleep well. I mean, we could express this angle with sine, cosine, or tangent. Like, which one is right? Yeah, I almost wonder if thinking about triangles as a bait, we should be thinking about a different shape. Like, we should be thinking about the square or something. Hmm. Oh, you can hear that. I'm like fiddling with my jacket, and I didn't realize that my mic was picking that up. I think it was kind of quiet, but I just noticed the level of my mic going up when I was doing that. Maybe, um, maybe we law of cosines on this big triangle. Seems like a reasonable try. BK, Burger King squared, is equal to 3 squared plus 5 squared minus 2 times 3 times 5 times cosine. You got the answer, but messy. Okay. This is 90 degrees plus this angle here, which we have an option for how to express it. I guess we should go for arc cosine. Same thing? Okay. Nope, we might want arc sine. Because of cofunctions. Yeah, let's go for arc sine. That's 4 over 5. And then cosine of 90 degrees plus something. I bet that's negative sine? Okay, if you take cosine and add 90 degrees. Oh my god, I'm so bad at this. I think you left shift. It's always the reverse of what I think. I think it's a left shift. I'm gonna look it up. I'm using Desmos. I don't care if it's cheating. Cosine of x is like that. Cosine of x plus pi over 2. Oh, it's negative sine. I did it wrong. Okay. 9 plus 25 is 34. Plus, because of negative sine. Oh, yeah, I should have just done the sum formula. I was thinking about it in terms of function translations, but the cosine of something plus something, I actually do have that. It's cosine cosine minus sine sine. But yeah, this right here is why I chose arc sine, because I knew we would get some kind of sine. Uh, 40? No. 34 plus 24. 58. What a dumb number. Do any perfect squares even go into your 2 and 29? Ew. Okay, well that's a number. What if we continue the 3 side and draw the perpendicular from B? Ooh. There's a thought. And this work we just did would be helpful with that. Green on its sides 4 and 3. Because the hypotenuse is 5? Now, the way I drew it, I would say 4 and 3 like this, but how do I know I didn't just draw it not to scale? Like, I don't know. Oh, no. Okay. Oh, wait. We could verify it with oh, yeah, with Pythagorean theorem on the big one. 7 squared plus 9. Yeah. Okay, that's how you know. Because, yeah. Oh, okay, okay. Oh, Pooey, fantastic idea. Yeah. Because now we have tangent of this angle is 3/7. A. Oh, nice. Great call, Pooey. Got the original altitude drops, not that bad, messy, no law of cosines. Really? I wasn't sure where to go with that. With this one here. So I was thinking like you would need to like somehow divide up BK, and it just kept getting weirder and weirder. Wow, that's a hard thing to spot. All right, well, Lucas went to bed, but now we know the answer. I might go back to latexing up homework and then calling the stream. How far am I into this solution? I'm pretty close to the end. Unless someone wants to distract me again, which I wouldn't mind. The 5x5 square they gave us was hidden in a bigger 7x7 square. Ooh, could we think of it like that? Where would the 7x7 square be? It would be... something like that, which is kind of crazy. I'm not trying to scale, but... Oh, yeah! Oh, yeah, that's really cool, Fembox. It is. Like, if I straightened it out, you have a big 7x7 square, and then this, like, 5x5 square that's rotated inside of it. And they just cut away the extra pieces. That's really cool. It's like they just erased that and that. I guess that too. Or no, not that. Maybe, I don't know. Something like that. That's cool. Welcome back, Caller Cone. Okay. Looking up the exercise for the Riemann surface stream. So you have in mind use the derivative of the determinant. Combination as the Dawn theorem. That's one that you like. You made me compute that, and I had no clue what I was doing. I could sort of have to it, and then you fed me the rest of the steps. I think I remember. Slash tau uv or 0v is 0, and slash tau 1v equals 0. Taking the Fourier transform of the Laplace equation with tau in v. How's the homework been going? It's been going pretty well. It's in a much better place than I was on Saturday. And in general, I feel like I can actually like get through the stuff that I've been assigned, which I was nervous that I wouldn't be able to last week. Even up to yesterday too. So I'll change my name to Jacoby. I think Jacoby should have to change his name to what's my last name? I'll just say factorial. Well, I don't have a reason to be secret about my last name anymore. It's kind of easy to find online now. But yeah, no, so I can actually get through my homework. So I'm feeling better about getting through everything by the end of the quarter. Which, speaking of, I only have one more class this week on Wednesday morning. That's tomorrow. Tomorrow morning. And then there's next week of lectures, and then it's finals. So it's coming up quick. But this homework is due on Monday. I've got another homework for scientific computing that's due next Friday. 2 final projects, and then a final test to study for. We apparently get a little like index card that we can put anything we want on it and bring with us to the exam. So I'm gonna have to make that. And that final test is for this complex analysis class. Yeah, so it's like the last homework assignment I have for this complex analysis class. My homework for my biology class is already all done. Just a final project for that. Which I made good progress on. I've written some good code. And I think my group mates have too now. The scientific computing is going to be really annoying. So I have a full homework assignment, which they always take me forever, which is this thing right here. And then there's also a final project, which I need to figure out what I'm going to do for it. Actually, you know what? I was talking to Fizzbuzz about it, because I want to see if he had any interesting PDEs to solve. And he showed me this kind of sick website. Let me show it off. Carl Jacoby? That's a weird name, Carl. It's visualpd.com. They made Turing with one of Turing's differential equations. And it's just a bunch of visualizations of PDEs. There's a really cool one that I liked. A bunch of these are really cool. One of my favorites that I found when I was looking through this, there's something called Berger's equation, which is kind of funny. The simulation wasn't that interesting though. Where is it? It is. This one was one of my favorites. There were a few really cool ones in here. I did a baby version of these for homework. At the start of one of my classes. But like, I think like this looks really cool. equation that governs shock waves. Used for supersonic plane. Ooh, that's cool. Yeah, it's like this grows rings, and they're stable. It's super cool. So you can even do like a funky shape too. This reminds me of one of those things from Metroid. Maybe it's just a brain. I don't know. I forget. There's another like really cool one. I can't remember which one it was though. Probably one relation in France they teach weak solution to PD to engineer students. That makes sense. These are visualizations of PDEs. It's a really cool website. They have like, it feels like they have every PDE you could think of here. In like interactive simulations for all of them. So there's a lot of really cool patterns that happen. Ooh, this is fun. Huh. After you disturb it enough, it kind of stops. Oh, dude, that's so cool. But yeah. Oh, yeah, yeah, the Concord. Cool PD website. Another library of all the rings. Oh, like abstract algebra rings? I don't know about that. Oh, this is the other one I was thinking of, I think. There's some really cool patterns that... This is it's not the same. It looks... Maybe this isn't the one I was thinking of. That reminds me... That looks very similar to the Fitzhugh Nagumo. Anyway. Oh my god. It is ring theory. Complete? What's the completion bit? Oh, this C is for continuous, not for complex. Oh my god. Bruh. Oh, for whether all the properties are known? Oh my god. Wow. What nerd made this website? How many are there? Do they have a count? That's not that many, to be honest. This is a lot, but I thought there'd be like way more. Wow. Now I know that exists. I can't say that I'm happier, but I can say that I know it exists. Oh, am I gonna do capital tau for the Fourier transform of tau? Wait. Do you... Excuse me? Where is my capital tau? Overleaf? Visualize... I don't know what that means, color cone. The new I don't know what... I've only been using Overleaf for the last like few months. I don't know what the old one is like. Am I just like, why is there no capital tau? We could do tau hat, I guess. Problem for Dessen? Okay. Denoted slash hat tau, I guess. If you don't know what to do with the transform of a variable, put a hat on it. If you like it, you should have put a hat on it. This assumes that we have to put this step in. When you take the Fourier transform of a derivative, you have to assume that I need to go back to my notebook and see the exact assumption that we're making. That e to the I lambda v times the derivative of tau goes to 0. Yes, here it is. E to the I lambda v slash partial slash partial v slash tau this looks really stupid. I was trying to avoid having a fraction inline, but I'm going to do it. Slash 2, 0. As v slash 2 slash pm infinity. I will verify this towards the end. To know the ideals first, if your brain is wrought by category theory, you should say spec r equals r, but all the morphism goes backwards. I'll have to believe you. Oh shoot, is Frog Thick here? I just noticed that they posted something in the Discord. A lot of things, oh my god. Frog Thick, if you say something in chat, we can talk about it. But if you're not here, I'm just gonna keep on working on this because I want to end the stream soon. And I'll get back to you in a message. Verify assumption. I'm writing a note to myself. To remind myself to actually follow through on this and verify it. Becomes an ordinary differential equation in U. The solution is null Stellan sets slash lambda U minus slash lambda U no, that's mostly because of my ignorance with LaTeX. What does that change? I obtain a slash tau 0v equals 0 equals a of lambda plus b of lambda. All my LaTeX knowledge is learning by doing. There's a lot of fundamental things about LaTeX that I just don't know because of that. A of lambda e to the lambda. Oop, not capital E. B of lambda e to the minus lambda. So a of lambda equals b of lambda equals 0. And tau of ub equals 0. Our favorite function, 0. Oh yeah, okay, Stephen Curry. I was waiting for you to say something in chat. You posted a lot of things. I won't do all of these things for you, but we can talk about these. Oh, is this a French song? That's how Grochenig defined affine scheme. No, we were reading last time. Begin proof is the inner workings of the package AMS theorem. AMS. Oh. Even that, I don't know what that really means, to be honest. Because I'm that bad with LaTeX. Oh, that's Dr. Cook. BizBuzz. And hi, Dr. Cook. Can I score a 3-pointer for him? He should score the 3-pointer for me. Okay, yeah, sure. We can do that. There he is on the Twitch side. Putting every single preamble in every single environment possible in one LaTeX, then you just experimented. Oh, that's a good idea. Positive versus negative versus a 0 versus an undefined slope. What the hell does that mean? Oh, okay. I was like, a positive slope or a negative slope. Okay. So yeah, these are kind of conceptual questions. So I'll kind of give the outline of how you would think about them. Pretend you have, like, just take any generic function you want. I'm just going to draw a squiggle here. Call it f of x. So when they're talking about, are they talking about, I'm sorry. I'm going too advanced here. I see later down, you're talking about y equals mx plus b. Okay. Really, we should start with number 3. I want to start with number 3 here. Grade 10 to 11? Okay. Yeah, sure, Destin. It might be good to see what's out there. Okay, so describe each letter in the equation y equals mx plus b. Well, I guess the two kind of quote-unquote easy ones are x and y. Y is the output. You might call it a dependent variable. Depending on the class. It's just whatever you get out after doing the stuff on the right side. X is your input, sometimes called independent variable. Because that's the thing you're plugging things into. Y depends on X, but we don't think of X as depending on Y, usually. Hey, Rex. How enum fields in matter works, you can teach it, Noish. The two more interesting things with the equation are M and B. So M is the thing multiplying x. And I've tried to think of a way to reinvent the wheel to explain this, but I think it maybe the best way that's coming to mind is just the way that I was taught it, which is that m is called your slope. And you can think of the slope as rise over run. Over as in division. And what that means visually is that if I draw some x and y axes here, and I have a line that goes, let's say, like that. Pick a point on the line, preferably an easy point, like this one right here, -1, 0. The slope is kind of I guess pick two easy points. I'm sorry. I'm trying to think of how to explain this on the fly, so I'm not doing as good a job as I can. So one easy point is -1, 0. Another easy point is 0, 2. What the slope means is, in order to get from like this first point to the second point, we have to rise by 2, and we run by 1. So that's what it means. Like, rise is the vertical distance, run is the horizontal distance. And you can do it with any 2 points you want, but it's easiest to choose points like these that are on the axes, or just like they're one apart from each other. So for this line, I would say that m is equal to the rise, which is 2, divided by the run, which is 1. So it's just 2. And no matter what 2 points you choose, you should always get that same 2. That's what m means. And now b is, it's what you're adding to mx. It's just kind of an offset. The term that they're really looking for is y-intercept, which is built into question 2, which is why I wanted to do 3 first. Well, really, we should have done question 4 first. Now that I read it, these questions are backwards. I'm sorry. B is called the y-intercept, or it's called the y-intercept because that's where it hits the y-axis. When you plug in 0 for x, you just get a big fat 0 there, and so you only have b left. So visually, when you plug in 0 for x, it means you're on the y-axis, and it's wherever the line hits the y-axis. So here, our y-intercept will be 2. And so really, we just found the 2 pieces of information we need to describe this line in green. We know the slope is 2, so y equals 2x, and the y-intercept was also 2, by coincidence. I like to homework looks nice. Math power level has grown a lot in the year I've known you. Well, thanks. Yeah, I mean, I guess learning complex analysis has unlocked a lot of math for me, I feel like. What do you have when you have a lawyer buried up to his neck in sand? Not enough sand. That's not a fortune. That's just a joke. Something quite about the most general way E and M can couple to matter. Bi-isotropic material. Oh my gosh. The 13th letter of the alphabet. Latin alphabet. True. Okay, so I think that answers number 3. Okay, actually, you know what? With number 1, I do see what they mean now with on a graph. This is an important one, so I kind of want to go through all these questions because this is really important to understand with lines. The quick way of recognizing positive versus negative. Positive slopes go up and to the right, like this line here that we talked about. A negative slope goes down and to the right, like something like that. A A zero slope is just a flat horizontal line like that. You think there's like just the equation y equals b, there's no longer an mx because m is 0. Undefined slope is a vertical line. And the reason for that is it's a little bit weird. But you may have learned with functions. It's okay if you haven't learned this yet, but it's something called like the vertical line test. Where in order for something to be a function, it has to pass this vertical line test. And if the slope is undefined, it's just a vertical line. It's definitely not a function. And so it's kind of like weird behavior happens. This comes up a lot in higher levels of math, and so it's hard to describe it right now. But for now, like, just believe that if your slope is undefined, it's a vertical line. And there's a good reason for that. It's hard to express, though. The definition of an intercept, I assume it's just where a function touches an axis. So y-intercept is where a function touches the y-axis, and x-intercept is where a function touches the x-axis. For number 4, what type of graph does y with mx plus b represent? It represents a line or a linear function if you want to be fancy. Recognize a graph that can be represented by it. If you ever just have a line of any sort, like a line like this, horizontal line, vertical line technically, but kind of, it's a linear function that can be represented by that. Okay. Let me know if you have any questions on that. If not, moving on to the next screenshot. This one's a little bit blurry. Makes sense? Okay, good. In the figure below, the 4-meter metal ladder is making a 60-degree angle with the ground. How high does the ladder reach? How far is the base of the ladder from the wall? Okay, so I assume you're learning about sine, cosine, and maybe even like SOHCAHTOA if you're being taught that kind of acronym. Okay, good. So what they want you to do with this situation is recognize a right triangle in the real world. The wall forms one part of the right triangle. The ground forms another part. Well, the ladder isn't sliding here. This is just a trig problem. I didn't do it. I waited until chat did it for me. There was this really crazy, for me it was just crazy, like a statics problem with friction preventing the ladder from sliding. Like this one here. I cannot figure this one out though. You have to use torque, and I hardly remember torque. Oh, really? Yeah, I know. The wall being sloped just feels like insult to injury. Oh, thank you, Puika. Yeah, that's a better way of saying it. I'm just gonna keep on going with this question, but yeah, you're right. Honors freshman mechanics? Oh, nice. Oh god, please don't torture your students with that one. Okay, so the right triangle here, the wall and the ground make up kind of like the legs of the right triangle where the right angle is. Then the ladder is the hypotenuse. We're given the ladder is 4 meters long. And we're given the angle with the ground is 60. So that's all the information we need to solve a right triangle. So I'm going to draw it out to the right here just to take away the annoying real world stuff. Well, so wait, so are you doing an E&M class and an honors freshman mechanics class? We need to get both this length here and that length there. So when they have one angle to work with, so we're going to need to take, and we have the hypotenuse. So the things that we want to use here are, oh, they give them names, H and B. Okay. H is how high up the wall. So H is this here, B is that there. So we're going to take both sine and cosine of 60. Sine of 60 is opposite H over adjacent 4. Over hypotenuse 4. Ugh, I really shouldn't misspeak. Yeah, it's posted in my Discord server. I can just send it to you separately, though. Let me just do that now before I forget. Divide by 0. There. Thank you, Desson. Okay. So sine of 60, that happens to be a nice angle, and I have that memorized to know that it's root 3 divided by 2. Yeah. If you just use a calculator though and you get a decimal, that's completely fine. That's always a little bit hard to figure out with what students are allowed to use in class, so do it the way that you were taught. The only thing left to do here is to isolate H, so we can multiply each side of this equation by 4. And that'll do the trick. Here, the 2 on the bottom can cancel with the 4. The 4 becomes 2. So we just end up with H equals 2 root 3. And so if you use a calculator, you should get something that matches that. So that's our answer for H. The answer for B will come from cosine of the same angle. So cosine is adjacent B over hypotenuse 4. And so I know that cosine of 60 is 1/2 equals B over 4. So do the same thing, multiply each side by 4. You'll get B equals 2. Download the pic. I also shared and put it on Overleaf. Grothendieck, of course. Oh my god. Yeah, that has to be there. The cool. I just want to mix up the music. Junior E&M out of Griffiths, freshman mechanics out of Klepner, and Cow. I haven't heard of that one. Interesting. Are you like enjoying your job overall still? All right, so I'm gonna. This next problem is basically the same, so I'm gonna move on to the next screenshot. Once I hear a question. I don't want to deal with setting up a new Overleaf document right now, to be honest. I'd rather finish up answering these questions and then we can mess with that maybe, but it does. I have a premium account. Okay, so I'll just do one of these because the procedure will be the same for them all. Hey, Boral. By the way, making you label the axes. To learn slope and y-intercept? Oh no. As long as you know them now. Okay, so I'm just going to randomly choose maybe this one here. Teaching is a wonderful job. Sometimes I get frustrated with the student's academic ability. If I focus on the material itself, not to my enjoyment to their achievement, easier said than done. It's totally fine. Okay. That would definitely feel frustrating if it feels like they're not trying. I haven't taught in a classroom, so I can't like I can't truly understand that feeling, but I don't know. Okay, so with this one, we have d equals minus 2t plus 4. They're trying to confuse you with these different variable names, but whatever variable is on the left side here is going to be your y. Whatever variable is inside the equation will be your x. So if you wanted, you could think about it as... What the hell? I thought I changed the colors, but it didn't work. Y equals minus 2x plus 4. They do want us to label the axes, though, according to these variables. So t will go on the horizontal axis, and d will go on the vertical axis. But it's still just the same thing as your y and x axes. They're just trying to confuse you with different names. And then when you're graphing lines, it's usually easiest to start with b, your y-intercept, because you instantly know that's going to be on the y-axis. So we have positive 4 here. So we're going to go up 4. We know that's a point right there. Bam. And now the slope is minus 2. So we only need one other point to figure out this line. So we can use our slope for that. So slope is rise over run. So if we rise -2, it means we go down by 2. It's a little bit blurry, so it's hard to tell exactly where 2 is. And I made my dot really big. But you go like 1, 2 down, and then 1 to the right. And now that's another point right there. And now you just play connect the dots. And that's your graph right there. And so all these will follow the exact same procedure. And the only one that looks a little bit trickier is like this one here because of the 1/2 slope. But just remember your rise over run. Instead, you'll just rise 1 and go to the and run by 2. So it'll be something like that. But it's still the same procedure for all of these. Get up around 4 a.m., prepare my lecture for a few hours, give it, go home around noon and sleep, wake up, prepare problem sets. Jeez. That sounds like a 4 a.m. is early. But if it's working for you, easier than it looks, even with no idea what to do, you can come up with a topic in 10 minutes? Really? That I always, when I'm first starting out, I think I would feel pretty nervous and like over prepare. Oh, so now for this one, they want you to do the reverse. This is a lot of work. But it's really important to understand this. It's very frustrating when they don't seem to be giving good effort over time. After a few years of teaching, I realized I was driving myself crazy pretending their effort was a variable I could control. Okay, yeah. Especially with like, I imagine the freshman classes would be the most like variable with how people are like willing to engage with it. Okay, so we need to determine the equation of each of the lines shown. They have 2 points marked for all of these, so I assume they want us to use this. To use those points. There's a couple of different ways that I could show you for this. Let me show you 2 ways. I'll show like, this is like the easy case. And I'm calling it, I don't mean to call it easy, but it's this one's it's a little bit easier to do this one than say like this one here. And I'll show you why. The reason I'm calling this one easy, this one up here easier is that we're given this point here, which is a y intercept. So we instantly know one piece of the equation just by looking at it. We know that the y-intercept should be -1. The slope we can get by counting from this other point. So let's go from this point to this point, counting our rise and our run. So we're going to rise down, so negative numbers. 1, 2, 3, 4, 5. So it'll be -5 divided by 1, 2, 3, 4 run. So our slope is -5/4. Y-intercept is -1. Now we just plug it into y equals mx plus b. So y equals -x minus 5/4. 80-minute lecture takes me about 2.5 to 3 hours to prepare to my satisfaction. Things get much easier once you teach a class a second time. Yeah, I imagine that helps a lot when it's not your first rodeo. But when I hear the questions that some of the other students in my class ask, I'm like, man, if I was the professor, I don't think I'd be prepared to answer that. Like, it's kind of out there, or it relies on like a lot more advanced stuff, I guess. Okay, so let me show you that, like, this slightly harder situation here, because here we're not given the y-intercept. At least it's not like it's somewhere off the chart up here. Oops. So we don't get to rely on that for this one. And so I hope that you've been shown the other form of a line. Well, there's... You know what? No. I don't need to go there. There's a different formula that I could teach you. I think it's better just to use y equals mx plus b, actually, if that's what you're being taught. So we don't know the y-intercept, but we can figure out the slope. So let's start with that. Starting from this point here, going up to that point there, we're going to rise 1, 2, 3, 4, and run 1. So 4 divided by 1, or that's just 4. Obi, thank you so much for the raid. I saw you were playing 9 Souls. I hope that went well. Welcome in. We've just been helping out Stephen Curry, if you can believe it, with learning about linear functions. Destin, I see your chat. I'll read that in a second. Yeah, I hope that 9 Souls was fun. Took an hour of grinding to get to the next boss. Fair enough. What it takes sometimes. That game looks pretty cool. So yeah, the slope here is 4. Destin with the meme raid, thank you. Double jump, hell yeah. Okay, so slope is 4, and so we don't know the y-intercept yet, but let's write what we can write so far. Y equals 4x plus b. We want to find b, we can't read it off the graph, so the backup plan is we can take one of these points and plug it in for x and y to find b. So this point looks easier because the numbers are smaller. That point is -1. Oops, sorry. I don't know math. -2, comma 1. So -2 is x, y is 1. Plug those in. Y is equal to 4. Looks like a 9. 4 times -2 plus b. Now solve this equation for b. So 1 is equal to -8 plus b, doing 4 times -2. Now we add 8 to each side. And so we get 9 equals b. And that's our answer there. 9, y equals 4x plus, 9. You had more people? No worries. Twitch is sometimes weird with the raids and the viewer counts in general. I appreciate any amount, though. Watching a Grothendieck biography documentary on my stream. What do you mean, meme raid? Oh, yeah, I'm sure. Then whoops, it was just me. Okay, So the only other tricky cases that I see on the sheet here are these flat lines. And so remember the horizontal line has 0 slope. You're just going to get y equals a single number. There will be no x there. Okay. Yeah, so we thought about the flat lines a bit more then. So yeah, if you try to do your same rise over run trick here, you'll just get 0 because you rise by 0 and you run by 1. So it's basically a 0x, but anything times 0 is 0. So don't bother writing it. We can still find our y-intercept though. That's right there. So it's -1. So let's say our slope is 0, y-intercept is -1. We can still do y equals mx plus b. It's just that we just get y equals -1 because the slope is 0. Rise by 0, run by 10,000. Yeah, or not 10,000, but whatever that is. Yeah. And then with the other flat line, the vertical one here, 1e9. There we go. A billion. L? You know, FA, you can't just come in here and hand out an L, okay? Those are meant for you. I thought you had fun on the mollusk. LL? Hey! Take those L's back. Oh yeah, so for this last situation, let's try to do the rise over run thing again. Starting from this point. We're rising 2, but then running by 0. So the rise over run is 2 divided by 0. But, uh-oh, you know, we're not allowed to divide by 0. This is not a good thing to get for your slope. So we call this an undefined slope. Because we're not allowed to divide by 0. That just kind of breaks the rules of math. So I would say slope is undefined. And this is a weird situation, like the y-intercept, I don't know what they want for the answer here, because it's kind of every single number. It's just the y-axis. So I'm not sure what they're expecting there. But it's literally any number you want. 0, 1, 2, pi, 1/2, -1. Like, you could put all numbers, I guess. But I don't know what your teacher would want there. Please don't divide by 0. Stop. Well, just because you told me to stop, I'm going to divide by 0 so hard. You ask her tomorrow? Okay. You swear you have a crush on me? I can't go south? Oh. That's how it goes. And then, so the equation is going to be, for vertical lines, it's actually, for a horizontal line, we have y equals a number. For vertical lines, we have x equals a number. And here, it's right on the y-axis. X is always 0. If you had this vertical line here, it would be x equals 3. Because it's all the points that have 3 for an x value, basically. And this would have no y-intercepts. So that's why it's a little bit weird to... It's like the one case where you do have y-intercepts, but it's all of them. I should create a DayZ club at my university. That'll be a great one-person club. So yeah, I hope that helps you out, Stephen Curry. Let me know if you have any more questions about that. But otherwise, I'm gonna leave it there. I think for the stuff you posted. I never read your message from before. I'm sorry. It's frustrating, but from my experience, I found peace when I understood they will not study math as a career. Focus on whatever they liked instead. Motivate math from that point. I love that attitude. A student, for instance, wanted to sell cosmetic products. I'd advise you have to be well versed in dynamics of local economics to be able to administer your business. Not only stop with cosmetics, but offer spa sessions, even offer travel experience of beauty. Oh, hey. Yeah, that, like, you might not need, like, super advanced math, but you do need to be able to, like, think critically with math to do that. So I like that attitude a lot. Sounds good. Thank you for the question. Crazy how since little kids we were dealing with the most basic line bundle. Oh, is this a line bundle? Just a single line? What time is it? Ah, it's 6:20. Do I finish this latexing or do I make food? Food? That's 1 vote. That's 2 votes for food. What food? Oh, okay, yeah, that's true, Destin. We can, okay, that's how we'll end stream. We'll look at Destin's latex. That shouldn't take long. Let me make a new project and copy paste it in. Dawn is awesome.txt. Oh, there's like 300 lines. I need to download this. Accidental last name reveal. I don't really care that much. What do I delete? Does this go like up here? You also need the image, don't you? Let me upload the image first. My real name is Dawn Daisy. Delete the whole thing? Okay. Just saving the image to my computer so I can upload it. Man.jpg. All right, let's see what you got. Oh my god. Oh, that's such a fancy header for the table of contents. Oh my god. Nice. You know, it says complex analysis. You should really make this your autobiography, though. Just confuse people with a picture of Grothendieck on it. Alright, well, 2 thumbs up. Okay. If you create a chapter... slash chapter in the beginning slash section. There was Dawn. Slash begin Dawn's theorem. 69 equals 69. Nice. What is it complaining about? Don's theorem undefined. Bruh. 6-7 equals 6-7. That's very fancy though, Dessen. I'll give you that. I think we're gonna call it there though. It's supposed to be. Oh, really? That's why. That's how bad I am at LaTeX. I didn't even know that. There we go. Much nicer. Okay. Now that's the end. So yeah, I'm gonna cut the YouTube stream off here, and then on Twitch we'll look for a raid. Stephen Curry, anyone else who's here on YouTube, thanks for being here. We'll be back, maybe even tomorrow. Stream is ending? Yeah, collar cone. I want food.